In this video, I'm going to be showing you how to determine the number of significant figures in your final answer when multiplying or dividing two or more numbers. When multiplying or dividing two or more numbers or values, the final answer that you get will exhibit the least number of significant figures from the original values used in the problem. This is different because when you add or subtract values, you take the least number of decimal places, while when multiplying or dividing, you take the least number of significant figures for your final answer. Now that we know this rule, let's put it into action with a couple of examples. Let's start off with the first problem, solving for the density of an object. Remember that density is equal to mass over volume. Let's say we had a substance with a mass of 12.82 grams, and its volume was equal to 14 centimeters cubed. To find the density of this substance, we would do the mass 12.82 over 14. So it would look something like this. After doing 12.82 divided by 14, we get 0.888 repeating. However, since the 14 in the denominator only has two significant figures, our final answer will only have two significant figures. As a result, our final answer will not be 0.888 repeating, but rather 0.89 grams per centimeter cubed. This is your final answer. Now let's look at an example with multiplication of three or more values. Let's say we were trying to find the probability of three events happening at the same time. The probability of the first event is 0.9. The probability of the second event is 0.75. And the probability of the third event is 0.425. To find the probability of these events happening at the same time, we need to multiply these values together in order to get a final answer. However, each of these values has a different number of significant figures, as the 0.9 has 1, this 0.75 has 2, and that last 425 has 3 significant figures. After multiplying these values out, you get the answer 0.2869. However, due to the 0.9 probability having only one significant figure, this must be rounded to one significant figure rather than the 4 significant figures shown in the final answer. As a result, your final probability changes from the 0.2869 to simply 0.3, as this value would be consistent with one significant figure. Although in this example, the answer and rule look similar to adding and subtracting, since 0.9 also has the least number of decimal places, this would not be the case if you had a value such as 500.5 times, let's say, 0.90. In this case, the 500.5 has only one decimal place in the 0.5, but it has 4 significant figures, while this 0.90 has 2 significant figures, but 2 decimal places. So rather than taking only one decimal place, you take 2 significant figures when multiplying these values, and the final answer would have 2 sig figs as the correct and final answer. And that is the end of this video. I hope you guys enjoyed it and found it helpful. If you enjoyed this video and like this content, please leave a like or subscribe, and I will see you guys in the next one.